This video looks at a Year 4 approach to teaching digital technologies. The approach starts with preparing students by working through a series of unplugged computing activities. Students will look at how peripheral digital devices use computing design elements to communicate code. So prior to starting this unit, the teacher has been reading a book, The Person Control by David Baddiel. The story centres around a magical video game controller that pairs with a bracelet to control the movements of whoever is wearing the bracelet. Students work towards creating their own paper version of this game controller in this unit and writing basic when and then algorithms to control a partner around a chalked floor grid. The creator of Hello Ruby, Linda Liukas, has pointed out that children often are very good consumers of technology. However, the real essence of computing design is hidden from them through layers upon layers of abstract user interfacing. This activity uses material design from the Hello Ruby website that she created. Students name the various elements of a computer, the ROM, RAM, CPU, etc., and create paper computers to reveal how these elements are used in computer designs.
I remember everything just now. And I only forget when you tell me off.
These activities lead up to the product and process skills required by the Design and Technologies curriculum. Using the Hopscotch Coding App, students define problems and solve them using a sequence of steps with increasing layers of decision making. Hopscotch provides video tutorials that are user-friendly. And in this activity, students would follow through the steps within the algorithm's video tutorial. Teachers need to be aware that students require some pre-existing mathematics knowledge around X and Y coordinates, basic percentages, and using greater than or less than symbols, which are all parts or components of the Year 4 maths curriculum. The end result of this video tutorial is the creation of a game that gives users the opportunity to grow a garden by tilting their mobile device. The opening segments of the tutorial assists users in using shapes and emojis to create the picture of the cloud, the raindrop and the seedling. From here, the tutorial has 5 key elements that we will look at here. The first activity is concerned with getting the raindrop to constantly drip from the cloud. And this requires a basic algorithm. When the game starts, an object will change in relation to its X and Y coordinates. Then users control the change of movement of the raindrop by creating a loop. Users code the raindrop to repeat forever and then adapt this into a new rule or code that can be used later to save time in repeating this same set of instructions. The second key stage is concerned with having the seedling grow a little every time a raindrop bumps the seedling. This activity requires students to be able to reference growth as a percentage. At stage 3, we now want the seedling to change into a flower at a certain point, so we use a branching code to do this. For example, if the seedling has reached a certain size, so if this statement is true, then a sunflower will appear in its place. Likewise, if this statement is not true, the seedling will continue to grow incrementally according to the previous code. By stage 4, we have a simple set of algorithms and loops that can be replicated to build a video game. We add more seedlings and use our grow flower rule or code for each seedling. In the final stage of the activity, users return to the cloud picture and add code that uses a when-if pattern. When the iPad or iPhone is tilted right, then X, the raindrop, moves in that direction. And likewise, when the phone is tilted to the left, then the raindrop moves in that direction. This part of the activity is key to creating a link between student coding practice and understanding the user interface. Students have created code and built this code into a video game. They then can play their code, essentially returning to their initial roles as consumers of digital technology, however, with a more concrete understanding of how these systems operate beneath the abstraction of user interfaces.